Okay, so for Algebra 2, this is 1.5 notes. Starting to look at solving inequalities. So if we're looking, Cooney is trying to decide between two rate plans offered by a wireless phone company. So here's plan 1, here's plan 2. A little bit different setup. So now if we start to look at this and start thinking about inequalities. So write an inequality to compare the price of plan 1 to the price of plan 2. So very, very simple. Plan 1 is $35, plan 2 is $55. So 35 is going to be less than 55. So that's nice and easy. Number 2, write an inequality to compare the price of the additional minutes in plan 1 to the additional minutes in plan 2. So as we start to look at this, plan 1, additional minutes are 40 cents. Plan 2, additional minutes are 35 cents. So an inequality to represent that is going to be this. So this is just going to be 35 cents a minute for plan 2 is going to be less than 40 cents a minute for plan 1. So plan 1 is cheaper up front, but it's 40 cents a minute after you hit your minutes included. Plan 2 is a little more expensive up front, but it's cheaper the more minutes you go. So if you know you're going to use no more than 400 minutes, all right, which plan is best for her? So no more than 400 minutes. So now this is where you got to think a little bit. If it's only 400 minutes, that means she's only going to pay 35 bucks. It doesn't make a lot of sense for her to do this one. So for 400 minutes, the best plan for her is going to be plan 1. Now, if she's a talker and she wants to use 1,000 minutes a month, which one's going to be the best bet for her? So now here's where you got to kind of think a little bit. So plan 1 is going to be 35 bucks plus 40 cents times every minute over 400. Okay, so if she goes 1,000 minutes, that means 600 minutes are going to be charged at 40 cents. All right, plan 2 is going to be $55, straight up always. But that's only going to be 35 cents a minute after that. And that's going to be 35 times, since it's 1,000 minutes and 650 of them are free, that means 350 minutes of them are going to be charged at that 35 cents. So it's going to be $55 plus 0.35 times 350. That's what you're looking at for your total cost. All right. So now a little math, a little calculator action, and let's see what we got. So 35 bucks plus 40 times 600, or 0.4 times 600 plus 35. This is going to cost you $275. There's plan 2, 0.35 times 350 plus 55. This is going to cost you $177.50. So that's a lot of money for it's a lot of money for a cell phone plan per month. But if you're going to use 1,000, you're going to use 1,000. So plan 2 is going to be best. So up front, plan 1, you know, if you're not much of a talker on the phone, it's probably going to be a better bet. But plan 2, if you talk a lot or spend a lot of time on the phone, that's going to be a better month. That's going to be a better deal for you. Okay, so solving inequalities. It's just like solving equations, except you've got to remember, you're not looking for one or two answers, you're looking for multiple answers. So when I look at this and solve, I'm going to treat it like an equal sign and kind of follow my rules. So add 9, that zeroes out. 11y is greater than 22, divide by 11, this becomes 1, y is bigger than 2. So now on a number line, since this is only greater than, it's not greater than or equal to, this is going to be an open circle, and all the numbers bigger than 2. So I go this way. Some people like to shade this part in. Either way, I'm fine with, but just something to indicate that I go this way. So how's that change when I've got this greater than or equal to sign on it? Well, here's kind of how it changes. It changes in the graph. Up here, you're still following the same rules. Subtract 9, so that's 0. 7x greater than or equal to negative 12 minus 9, that's a negative 21. Now I divide by 7, divide by 7. X is greater than or equal to negative 3. Now, some of you guys might remember, in inequalities, with inequalities, so symbols like this or pointed the other direction, or like the problem we just had, there was something to do with negatives where I had to change the sign. And here's kind of that rule. If I multiply or divide by a negative number, I switch the sign. Let me say that again. If I multiply or divide by a negative number, I switch the sign. This is not negative. I divided by 7. That's positive 7. That's not negative. So that means I don't change the sign. I keep it as is. Okay? I'll show you one in a second where we will change the sign. So you're looking at negative 3. Because this is greater than or equal to the sign, I'm going to fill that in, and I'm still going right. All right, because this is going to be greater than or equal to. So let's take a look here. Oh. So let's take a look here. 2n minus 6 divided by 5 plus 1 equals 0. So use an open dot for less than or greater than. Use a filled dot or a closed dot for less than or equal to or greater than or equal to. All right, make sure if it's one of these, it's a filled dot. If it's just these, then it's an open dot. So let's take a look. 2n minus 6 divided by 5 plus 1. Plus 1 is greater than 0. So if I subtract 1 over, multiply it by 5, and move these back over. Come on. So this becomes 2n minus 6 greater than negative 5. So add 6, that zeroes out. 2n is greater than 1, divided by 2, and it's got to be bigger than 1/2. So now, this is just greater than, so that's 0, 1, 2, 1/2 is going to be right here. It's an open circle, and I'm going bigger. So solve and graph 14 minus 8n is less than or equal to 0. So we want the number line. So take a look. So negative 14, negative 14. Just algebra rules coming back. So now, divide by negative 8, divide by negative 8. So this becomes n, but because I'm dividing by a negative right here, I switched directions with the sign. All right, because this is negative, I'm going to change this. So this becomes 1 6/8, better known as 1 3/4. So my original sign, I was pointing left. This time I'm pointing right. So n is greater than 1 3/4. 1 3/4 is going to be about right here. This is going to be a filled circle. I'm going to go that way. I don't want that one. I want this one. Put that right there. So let's kind of use some language here. Twice the sum of a number and 5 is no more than 3 times that same number increased by 11. So twice the sum of a number. A number becomes our variable. Twice the sum. Sum means addition. Twice the sum of a number and 5. So kind of what this means is you're going to go 2 times x plus 5 because it's twice the sum of a number and 5. Is no more than 3 times that same number increased by 11. So the handy part is that it's the same number, so I can use x again. So it's going to be 3 times that number plus 11. So no more than means it could be equal to. It's not going to be more than. It can be less than or equal to. So now it becomes just kind of a slightly messy algebra problem. A little distribution. A little subtraction going both directions. This becomes 0. This becomes 0. 3x minus 2x is x. That's going to be minus 1. So negative 1 is less than or equal to x. If you want to change that around, that's fine, but you just got to remember that the arrow's got to switch with it. So if I move x to the left and negative 1 to the right, the direction of the arrow's got to come with it. The arrow's got to stay pointed in the same direction. So number 10, 9 less than number is at most that same number divided by 2. So x minus 9 is at most that same number divided by 2. So that means that's got to be less than x divided by 2. So I want to multiply both sides by 2. So this left side will give me 2x minus 18. This side will just give me x. So now I'm going to kind of kill 2 birds with 1 stone. Subtract x, that zeroes out. Add 18, that zeroes out. So I'm left with x less than or equal to 18. There's my answer. Okay, so homemade bracelets are on sale for $4.75 each. Which inequality best used to find how many bracelets Caitlin can buy for herself and her friends if she wants to spend no more than $22? So take a moment, kind of see if you can think about this and work it out. Hit pause and look it over, and then when you're ready to go, hit play and see if you're right. Okay, so take a look. $4.75 for each bracelet. You only have 22 bucks to spend. So $22 is your high-end amount. You can't spend any more than $22. So, but you do get $4.75 for each one. So $4.75 times B means bracelets. So let's see kind of what we're looking at. So $4.75 per bracelet has got to be less than or equal to $22. So this one's wrong because right now you're saying each bracelet's worth $22, but you've only got $4.75 to spend. This one's saying 22 times the bracelet bigger than $4.75, so that doesn't work. This one is saying it's $4.75 per bracelet, but you're going to spend more than $22, so it's this one. So the Middletown High School girls basketball team wants to make at least $2,000 on their annual mulch sale. Team makes $250 on each bag of mulch sold. How much should they sell? So you've got to look at this. They make $2.50 on each bag of mulch. You got to make at least $2,000. So if I do this, how many bags of mulch do I need to sell? So that's going to be at least 800 bags of mulch. That's all I got. If you got any questions, please come in and talk to me.